So, welcome to our EDU Onyx programming course on C socket programming. So in this course, we're going to cover sockets and some of the low-level networking concepts surrounding them. Specifically, we're going to be talking about the C sockets API and the functions that are necessary to create sockets that will both act as clients and servers in various networking applications. This course assumes some basic, fundamental knowledge about the C programming language. We're going to be using things like functions, loops, basic aspects of the C programming language. So this knowledge is going to be helpful when we start dealing with socket code. Before we get too deep into the socket API, the different functions that we're going to need to be calling in order to set up sockets, the first thing that we'll look at very quickly is why sockets are important in network programming. So sockets are basically the low-level connection endpoint. They're the way that you can create a connection between any two computers, essentially. And there's a lot of protocols that sit on top of sockets. So things like TCP, which is our low-level networking protocol. And on top of that is built the high-level networking protocols like HTTP, the protocol that we use when we browse the web. And FTP, what you might use to upload files, or in a bunch of different cases, there's a lot of protocols that sit on top of the basic socket functionality. So these are some of the reasons why sockets are important. With just basic socket programming and these C APIs, you can implement applications that do any of these things. You can create web servers, web clients, FTP clients. Anything that interacts with the network can be built using the basic socket building block. So to start off, we're going to look at how to build a client socket. And I have client in quotations here because a socket is a two-way endpoint. So you can both send and receive information on any socket. There's no such thing as just a client socket or just a server socket. The socket is basically dependent on how you intend to use it. So we're going to build a client, so to speak, that will send and receive some data from a server, basically another socket endpoint. So the API that we're going to be looking at, there's a workflow that looks like this. So in order to create a client socket connection, the first part in any socket programming is you have to create the socket itself. In C, there's this socket function that you use. You can store the result of that socket function in an integer. That's basically a descriptor, and that's how we're going to refer to our socket. That integer will allow us to make any future calls on a particular socket after we've made this socket call. In the socket call, we specify basically the type of socket. In this case, we're going to work with TCP in our client and server. This will be a little bit easier since there's a lot of applications that will allow us to see TCP traffic and interact with it without having to write a whole bunch of extra tools in order to see what we're actually doing on the network. So when we create our socket, and we'll look at this in the actual code later, we specify what type and the protocol and sort of the domain, and these are kind of the basic things that we need to know to create the socket. After the socket's created, we need to connect it to some remote address. And that's basically where we specify the IP and the port that we're going to connect the socket to. From there, once it's connected, if we have a successful connection, you'll get back a return value that indicates that your connection was successful, and then you can start sending and receiving data. For our client, in this case, we'll just have receive here, since we'll have something else send it data. Or in some cases, like if you were running an HTTP client, you might send first, make a request, and then receive data back as a response. But this receive function allows us to get data back from wherever the other side of the connection, whatever's on the other side of the connection, we can receive that data, and then we can print it out, store it, write it to a file, do whatever we want. We can read that data back basically into a string and then see what it looks like, do whatever we want with it. So before we jump right into actually doing some socket programming, one thing I want to mention really quick is, for simplicity, we're going to be doing all of our socket development here on a Linux environment. This would also work under Windows if you use Cygwin and GCC. It's going to be the exact same commands. Doing this under Linux is going to be a little bit easier since the tools and compiler and everything we're going to need is going to be already included in our operating system. But if you want to use these same tools on Windows, you can use the Cygwin environment and GCC, and the commands will be the exact same. You can basically compile your code in the same way and run it in the same way. And the libraries and API will be pretty much the same as well. But for the purposes of this course, we're going to focus on doing this in a Linux environment. So to get started, we're going to create our TCP client file. We're going to be using Vim as an editor here, just to keep it simple. So we're going to need to include some things from the standard library, standard IO and standard lib. We're going to need to include types and socket.h for definitions about the socket functions that we're going to be using. Socket.h is going to contain most of the important functionality and the API that we're going to be using to create our sockets. So, those includes look like this. And for some structures that we're going to need to store address information, we're going to need a header file called in.h under net inet. And then we can create our main function. So just as a quick double check before we keep going, these are all the includes you're going to need in order to make sure that you have all of the calls and types specified. So you'll need standard IO, standard library, and types and socket.h, and then make sure you include that in.h library. So once you've got all those ready, we can get started. So in this example, we're going to start writing our TCP client, and we're going to use the workflow that we described based on that diagram that we saw a little bit earlier in the slides. So first we need to create the socket, and that's the simple part. We can use an integer to hold the socket descriptor, and that basically is what's going to contain the information about our socket. Let's call this network socket, just to be verbose here. But you can call this whatever you actually want. And then you call the socket function like we showed earlier in the diagram, and you store the result of it in this integer. I'm going to comment this just so it's extra clear exactly what's happening at each step. So you call the socket function like this. The first parameter is basically the domain of the socket. We're going to, since it's an internet socket, we'll pass af_inet, and that's a constant that's been defined elsewhere for us to use in one of our header files. Sock stream is going to be the type of the socket, and that basically means it's a TCP socket, a connection socket, as opposed to a datagram socket, which is basically what the UDP protocol is. They work a little differently, TCP versus UDP, but in this case we're going to be using TCP. So the constant that we're going to use, it's already been defined, is going to be called sock_stream. And the last parameter specifies the protocol. We're just going to use 0 here since we already basically have to be using TCP. There's some other cases where we might want to specify the protocol explicitly, like if you're using raw sockets, which are sockets independent of an actual protocol in the way that we've been using them here. But we're going to specify 0. That means we're using the default protocol, TCP.